Hey, Precal kids, what's going on? So today we're going to be talking about something that we've talked about a little bit already, but just to kind of review some stuff that you probably should have already learned in Algebra 2. We're going to learn about complex numbers. All right, so essentially what is a complex number? It's basically just a combination of a real number and an imaginary number. So you've got one term that's a real number, and you've got another term that is an imaginary number. And it's written in this form, a plus bi, where the term a is your real part, and bi is obviously the imaginary part because it has the imaginary number I in it. Okay. Now if b is 0, okay, so in this, looking at this form, if b was 0, then the number is a real number, because the imaginary part is 0. There's 0 imaginaries, so you just have a real number. On the other side, if a is 0, then the number is an imaginary number. Not sure where the word number went, but I'm pretty sure I put it on there. Okay, so basically, if a is 0, then you just have an imaginary number. If b is 0, then you just have a real number. They're all complex numbers, okay? So if you have just a real part, if you just have a real number, that's also a complex number. An imaginary number is also a complex number. A combination of the two is a complex number, okay? So here's some examples. You could have 3. That's just the real number, right? That would be 3 plus 0i. That's when b is 0. So that's 3. You could have, 0 plus 2i. That's just an imaginary number. It's also complex, right? Complex number, any number is a complex number. Real, imaginary, rational, irrational, they're all complex, okay? Complex is kind of a number you can use, a term that you can use for any kind of number that we have ever used in all of math, all right? But this part would just be considered an imaginary number because the real number part's 0. You wouldn't have to write the 0, just got right there just to write it in complex number form. Then you could have ones like -1 plus 3i, and you could have 2 minus 5i. Well, those are going to have an imaginary part and a real number part. Okay, so what exactly is I anyways? So I is what we use to denote taking the square root of -1. So anytime you have the square root of a -1, we write I. Okay, so something a little bit different if you had the square root of -4. Well, you would do the square root of -1 times the square root of 4. So square root of -1 is I, and the square root of 4 is 2. So square root of -4 is really 2i. All right. Now, what is I squared? Okay, I squared. Something a little bit different. Well, think, what is I? I is the square root of -1. Well, if we square I, okay, then that's the same thing as squaring this side. So I squared equals the square root and the square root are just going to cancel out because they're opposites of each other. So that just is -1. So I squared is -1. All right. So that's something that's important to understand, that I squared is always -1, and obviously I is the square root of -1. So anytime you see a letter I used in a complex number, you know that means the square root of -1. Okay. So let's do some stuff with some complex numbers. First, we're going to look at just adding and subtracting. And this is really simple. You really just are adding and subtracting like terms, okay? It's nothing different than if it was an x. You just treat it like it's an x and add and subtract like terms. So right here, you got 3, and you're going to add 2, that's 5. You got -1i, and you're going to add 3i, that's 2i. Okay, so you're just combining like terms. I'm not multiplying those. Don't think because I drew those lines, I'm multiplying. I'm just showing you which terms are like and adding. Over here, we've got 3 different numbers this time. So I'm gonna take this minus and distribute it first. So 3 minus -2 is +2, minus 3i is -3i, and I've got plus -5i, or sorry, plus -5 and plus I. Okay, so that way you can write like this, just get rid of your parentheses, and then you can combine your like terms. So I got 3 plus 2 minus 5, well that's going to be 0, and I got -3i plus I, it's going to be -2i. So I got 0 minus 2i, or you can just write -2i. All right. So go ahead and pause the video and you guys try the U-tries. Let me know if you have any questions. Now, so for the first one, you got to make sure you distribute the minus. So when you do that, combine your like terms, you get -3 plus 0i in complex number form, which simplifies to just -3. So that's just a real number. And then in B, you do the same thing, distribute your negative on the last complex number, 7 plus I, and then you combine all your like terms, and you actually get 0 plus 0i, which is just 0. So that's the complex number form of the number 0. So everything just cancels that out. Okay, so let's look now at multiplying complex numbers, which is where we're going to actually end up using I squareds. So again, you treat it just like an x. Okay, 5 times -2 is -10. 5 times 3 is 15i. Okay, it can be that simple. Now, the only complicated part is if you get an I squared, but we already know what I squared. Remember, I squared equals -1, right? So we talked about that on the first slide. So right here, we've got a FOIL. 2 times 4 is 8. 2 times 3i is 6i. -I times 4, -4i. And -I times 3i is -3i squared. Okay, now we've got 8. 6i minus 4i is 2i. And remember now, we've got I squared, -3i squared. I squared is really just -1. So -3 times -1 is +3. And now we can combine the +3 with the 8 and get 11 plus 2i. Anytime you add, subtract, or multiply or divide complex numbers, your answer should be able to be written as a complex number. Okay, so we should always be able to write it in the form a plus bi. So here's our answer for that one, 11 plus 2i. All right, you guys do the U-tries down at the bottom. Remember, if you get an I squared, just change it into a -1. All right, on the first one we distribute, you get -4i plus 20i squared. Of course, I squared is -1, so we replace the I squared with a -1. That gives us -4i, lost my negative there, -4i minus 20. Now, we want to switch it around, right, because the proper form is a plus bi. So even though we have -4i minus 20, we need to swap them and put -20 minus 4i to put it in proper complex form. Then on B part, you do your FOIL, distribute, and your two I terms, the imaginary terms, cancel out. So you're just left with 9 plus 4, which is 13. Okay, remember the I squareds become -1s. Okay, so that's multiplying. Now, one thing that you got to be aware of is on this B part right here that you do the U-try, those two things we multiplied are called conjugates. Okay, so we call them complex conjugates or conjugates. A conjugate is when you have the exact same terms, but the sign in the middle is different. So one of them is 3 plus 2i, and one of them is 3 minus 2i. Okay, so good opportunity to talk about conjugates because we're going to use those when we divide complex numbers right here on these next problems. Okay, so dividing complex numbers. So these are the most complicated ones. Whenever you're going to do a dividing complex numbers, the issue we run into is, remember, I is the square root of -1. Well, we can never leave a square root on the bottom of a fraction. So you can't leave it with an I on the bottom of a fraction, because really I is a square root. So we've got to get rid of the I. So what we're going to do is we're going to multiply by the denominator's complex conjugate. So I've got 2 plus 3i over 4 minus 2i. So what you want to do is figure out what's the conjugate of the denominator. 4 minus 2i. The conjugate of that is 4 plus 2i. The same terms, but you just change the sign in the middle. Multiply by that on bottom, and multiply by that on the top. Okay, so let's go ahead and take care of the top. Usually the top's just going to FOIL like normal. So you do 3 times 4, get 12. 3 times 2i is 6i. 3i times 4 is 12i. And 3i times 2i is 6i squared. Alright, and then on the bottom, when you multiply conjugates, just like that last problem, remember how the I terms canceled out? The 6i minus 6i just canceled? Well, that's going to happen here too. So you can save yourself some time when you multiply by a conjugate and you know it's a conjugate by just multiplying the first terms and multiplying the last two terms. 4 times 4 is 16. So we just multiply the first two terms and then multiply the last two terms. Because we know the other ones are going to cancel each other out. We're going to get 8i and minus 8i. So that gives us minus 4i squared. Alright, now let's change the I squareds to -1s and combine our like terms. So we've got 6i and 12i is 18i. Then we've got 6 times negative 1 is really 6 times I squared is really 6 times negative 1. 16 times 4 I squared is really 4 times negative 1. So we get 12 plus 18I minus 6. And on the bottom, we've got 16 plus 4. Right? So that's going to end up giving us on the top 12 minus 6 is 6 plus 18I. And on the bottom, we got 16 plus 4 is 20. Now, notice all three of these numbers are even, so we can reduce them all. The biggest thing that will go into all of them is 2. So we divide all of those by 2, and that gives us our simplified answer, 4 plus 9I over 10. All right. So you say, well, you said it's got to be, everything can be written as a complex number. Yes, so what we're going to do is rewrite this as 4 over 10 plus 9 over 10I. So there's our A plus B. 4 over 10 is A, and 9 over 10 is B. Of course, the 4 over 10 will reduce, so we write 2/5 over 9 over 10I. And if you wanted to take it right here and split it up right there and do 6 over 20 plus 18 over 20I and introduce your fractions, that's fine too. Okay, nothing wrong with doing it that way. So that's how you divide complex numbers. Let me know if you have any questions. Go ahead and try the one down here at the bottom of the screen. Okay, so right here you can see we multiply by the conjugate, which is 2 plus I, and that gave us 4 plus 2I plus 2I plus I squared on top, and 4 minus I squared on the bottom. Those middle terms cancel out since it's a conjugate. So then up top, we change our our I squared to negative 1, and we change I squared to negative 1 on the bottom. So now we've got 4 and minus 1 combined to give us 3. 4I up top, and then we got the minus 1 on the bottom. Subtracted from 4 makes it 5 on the bottom. So we got 3 plus 4I over 5. Then split it up into your A plus BI, 3 over 5 plus 4 over 5I. Okay, so now sometimes whenever we've got complex numbers, they're written as square roots, and we want to change them into complex number form, right? Because remember, if you have a square root of a negative, that is I. So right here with A part, let's look what we're going to do. We're going to take out a negative from the square root. Anytime you see that negative, just bring it out and put I. And leave square root of 3. All right, and then we can simplify this square root. We see a negative, so we're going to take out an I. But now also 12 can be split up into a square root of 4 and a square root of 3, right? And we split those up like that because 4, we can actually take the square root of it, right? It's a perfect square. So anytime you have numbers that you can take a square root of, they're perfect squares, you want to split those up and get those out of the square root. So we got I squared of 3 times the square root of 4 is 2, so we really have 2I squared of 3. Now you can multiply those together. 2I times I is 2I squared. Square root of 3 times square root of 3 is the square root of 9. All right, now we know I squared is negative 1, so really this is 2 times negative 1, and we know square root of 9 is 3. So we've got 2 times negative 1 times 3, which is negative 6. All right, let's look at B. Let's do it the same way. So we need to take an I out because we've got square root of a negative. Now 48, the biggest perfect square that goes into 48 is 16. So we split it up into square root of 16, square root of 3. And then we've got minus. Again, we've got an I. So we need to take biggest thing out of 27 is 9. Biggest perfect square. So 9 times 3 gives us 27. So really square root of 16 is 4I square root of 3 minus square root of 9 is 3I square root of 3. Okay, so now we're subtracting, right? Notice before we were multiplying, right here we're subtracting. So when you multiply square roots, you multiply the outsides and you multiply the insides, right? So we multiplied I and 2I, and we multiplied 3 and 3, right? And left the outside stuff on the outside, the inside stuff on the inside. Well, when you subtract or add square roots, something has to be in common for you to be able to add and subtract them. Okay, just like terms. Okay, you can't add 4x and 2y. They got to be like terms. Well, for square roots to be like terms, they have to have the same kind of root, right? They have to both be square roots. You can't have a cube root and a square root. You can't add those. And also, the number underneath has to be the same. So right here we see we got the square root of 3 and the square root of 3. So those are like terms because they have the same kind of root and the same number underneath. If both of those aren't existent right there, then you can't combine those. Right here we can't because they're both square roots and they both have a 3 underneath them. So we can combine those just like terms, just like we would with anything. We got 4i squared root of 3 minus 3i squared root of 3, so that's 1i squared root of 3. All right, that's how you would do a problem like that when you're adding or subtracting radicals. Okay, so C part right here, we're squaring something, so we need to multiply it by itself. All right, so we're going to FOIL. -1 times -1 is 1. -1 times square root of -3 is negative square root of -3. And then square root of -3 times -1 is another negative square root of -3. Square root of -3 times square root of -3 is the square root of 9. All right, but now remember when we do the, sorry, let me go back. Let's do it this way. This is the same way we did the first one. So let's change this to -1 plus I square root of 3. And -1 plus I square root of 3. Okay, let's do it this way. So -1 times -1 is 1. -1 times I square root of 3 is negative I square root of 3. And then another one is negative I square root of 3. Then I square root of 3 times I square root of 3 is I squared square root of 9. So we get 1 minus, now right here, remember these are like terms, right? We've got -1i squared root of 3 minus 1i squared root of 3. They're both square roots and they're both 3's in the bottom. So we can combine those. You get minus 2i squared root of 3. Then we've got plus I squared, which is really plus -1. And square root of 9 is really 3. So we've got 1 minus 2i squared root of 3 minus 3. Well, 1 and minus 3 give us minus 2. So we've got minus 2 minus 2. And we really should write it like this because that's proper A plus BI form. A is -2 and B is -2 square root of 3. And you got the I, right? So that's A plus BI form. Alright, let me know if you have any questions on those. I know this can be kind of confusing. Go ahead, when you see the square root of a negative, just go ahead and take an I out of it. Okay, get rid of that square root of a negative and just put an I right there with the square root. Okay. I know I had the i's in front of the square roots because it just helps me understand that that's not in the square root anymore. But once you're done, it's best to put the I after the square root because you need to have an A plus BI form. Okay, so the last thing we'll do is look at solving some equations that give us imaginary or complex solutions. So let's solve this first. We got x squared plus 4 equals 0. So we subtract 4, subtract 4. We get x squared equals -4. Then we take the square root. Of course, we always put plus minus in front. So we get x equals plus minus. And like we talked about earlier, the square root of negative is I and the square root of 4 is 2. So our answers are positive 2i and negative 2i. All right, let's do this other one right here. So we got 3x squared minus 2x plus 5 equals 0. It's a trinomial, so we can try factoring it. So we can try slide and divide x squared minus 2x plus 15. So the question is what multiplies to be 15 and adds up to be 2? Well, save you some time, there's not anything that will multiply to be 15 and add up to be 2. So this is one that cannot be factored. Okay, so whenever you've got a quadratic equation that you cannot factor, you need to use quadratic formula. So remember, this is A, this is B, and this is C. Quadratic formula is -b plus or minus the square root of b squared minus 4ac all over 2 times a. So let's just plug those in. -b, well, b is -2. So -2 plus or minus the square root of -2 squared minus 4 times a is 3 times c is 5. It's all over 2 times a, which is 3. -2 is 2. On the bottom, 2 times 3 is 6. We got plus minus the square root of some number. Well, whenever we multiply all that out, you can do it in the calculators, type it just like it looks. That's going to give us negative 54 or 56, I believe. So it's 4 times, 6, or 4 minus 60. So yeah, we get negative 56. So now you can see we've got the square root of a negative. So we're going to get some kind of imaginary solution or a complex solution. So we need to figure out what can we take out of the square root besides I. Well, square root of 56 is, let's see, 4 times 14. So we can take out the square root of 4 and square root of 14 over 6. So really that's going to be 2 plus or minus 2i square root of 14 over 6. So if we wrote our two zeros as complex numbers, we would get 2 over 6 plus 2 square root of 14 over 6i. And of course 2 over 6 minus 2 over 6 square root of 14i. But then that's going to reduce to 1 over 3 plus and minus 1 over 3 or square root of 14 over 3i. Alright, so that's plus and minus. Okay, those fractions go through this. Alright, give these next couple a try. I'm going to pause it and give those a try, and I'll go. X squared plus 25 equals 0. We just subtract 25, take the square root, and square root of negative 25 is positive and negative I. So your answers are plus 5i and minus 5i. Of course, if you wrote those as complex numbers, you'd write 0 plus 5i, 0 minus 5i. On the B part, you've got to do quadratic formula. Just save you time having to try to factor. If you try to factor, that's great, but it's not going to factor. So to plug in the quadratic formula, when we do that, we get negative 16 plus or minus the square root of negative 16 all over 8. Well, the square root of negative 16 is 4i, so you get negative 16 plus or minus 4i over 8. You split it up, negative 16 over 8 plus or minus 4 over 8i, and the negative 16 over 8 reduces to negative 2, and 4 over 8, of course, is 1/2. So you get negative 2 plus or minus 1/2i. All right, let me know if you have any questions about any of this stuff. I can help you out. Don't hesitate to ask. Here's some practice problems. Go ahead and start working on those, and let me know if you need help. Thanks.